Supplemental math videos from Circle Christian School. Points and lines. These are the essential building blocks of geometry. Without these, you can't do anything else. The Greeks did it the best first, had their little togas on, wrote in the sand. It was the big study of the day, that and philosophy. But surprisingly enough, geometry and philosophy go quite together. And eventually, the algebra melded into the geometry before it got lost in the Dark Ages. Okay, yes. Use a little bit of the segment addition postulate to find some distances between certain points. I'm going to start with the distance between A to B here. And you'll notice that it started with a -9 and ended with the -4, so it's going to be minus the -4. And we put the absolute value signs around it because distance is absolute and always positive. And we would get a -5, so there's a distance of 5. If you weren't sure, you could actually just count 1, 2, 3, 4, and 5. So it equals the absolute value of -5, which is going to be 5. Next, we're going to do from A to D. So we have the beginning place, A, which is a -8. And distance is always some sort of difference. And D is going to be a 4. So we have the absolute value of -12, so we have a distance of 12. And again, if you weren't sure, you can honestly just count and see how far away it is. Next, I'll do C to D. Make sure you identify it. Put your finger on it, touch it, go from C to D. Makes it a little bit easier. And again, we have the absolute value. Where did we begin? At -1. The difference in the distance, so a 4. That gives us a -5. So it has a distance of 5, an absolute value of 5. And again, if you're not sure, just count, like so. I am going to leave the other 5 for you to do. And you can check it when we get back to class. I'll give you the little answers for this, and you can get star points for it. Now, a word about congruency. Congruency is much like two things being equal to each other, but not only are they going to be similar in shape, they're going to be equal to each other. As a matter of fact, that's a little bit of what happens with the congruency symbol, which has this cute little sideways S, which actually means similar. And it has an equal sign underneath it, which means they're not only just similar, but they're also equal to each other. Now, when two things are congruent to each other, we use little tick marks to signify that things are congruent. So I'm just going to put a 1 little tick mark here and then a 1 little tick mark here. And basically what I am saying is that segment AB is congruent to segment CD. Now, when lengths are equal to each other, we will write AB is equal to CD. Anytime we're talking about measure of segments, it's not going to have the little line, and it's going to be equal to each other. Some people are picky about this, others not. I'm not exactly all that picky or particular about that, as long as I just know I'm going from A to B, and there's a equality happening from C to D. When you want to say segments are congruent to each other, you're going to put the little segment sign over it, write the little congruency thing, and then CD. And that's really about the only difference here. The big thing to remember is what happens with the little tick marks. So for instance, if I had two other lines that were maybe of a different length, let's say this is E and this is F sitting on the same page. And this is going to be segment GH. And I want to signify that EF is congruent to GH. And they're not the same size as A and B. I'm just going to give it 2 tick marks to say, hey, these guys are congruent to each other, but not congruent to A, B, or CD. And that's pretty much all you need to know about congruency at this point.